Hi everyone, today we will be solving question number 6 of February March 2025 paper 4-2. The question says the structural formula of two compounds A and B are shown. So this is the structural formula of compound A, this is the structural formula of compound B. A and B are the members of same homologous series. Now homologous series in organic chemistry means family. So they both belong to the same family. Can you figure it out that why both of them belong to the same family? Yes, because both of them are alkenes. They have double bond in them. So they are members of same family. Let's have a look on part A of the question. It says, give two reasons why the structural formulae of A and B, which are given, show they are the members of same homologous series or same family. So it's very simple. We can say that they both have same functional group, which is C double bond C. That is the functional group present here. Second reason what we can give is that both of them have the same general formula. Now let's verify this. The formula for compound A is C3H6 and the formula for compound B is C4H8, which means they both have the same general formula CnH2n. So these are the reasons we can give that why A and B belong to the same family or same homologous series. Let's do part number B. Explain why A and B are both hydrocarbons. Now, this is super simple. Hydrocarbons are the compounds that are made up of carbon and hydrogen only. That's why they are called hydrocarbons, hydrogen and carbon. So, we'll say that because they both are compounds made of carbon and hydrogen only. Please understand that the term only is very important to write here. The compounds that are made up of only carbon and hydrogen are called hydrocarbons. There should be no other element present in the compound. Part number C. Write the symbol equation for complete combustion of A. Now A is an alkene. Now whether it's an alkene, it's an alcohol or it's an alkane, all of these molecules will give carbon dioxide and water on combustion. Now because it's a combustion reaction, we will be reacting it with O2 and it will give us CO2, water and energy. I repeat, whether it's an alkane, alkene, or alcohol undergoing complete combustion, the products will be CO2, water, and energy. To balance it, it's easier to go the way balancing carbon first and then balancing hydrogen, and at last we'll balance oxygen. So I balanced carbons by putting a 3 here. Now I have 6 hydrogens and 2 hydrogens, so I'll multiply this by 3. Now my carbons and hydrogens are balanced. Carbon are 3 on both the sides, hydrogen are 6 on both the sides. As I said, we should always go in the order balancing carbon, then hydrogen, then oxygen. This should be the order. So now let's focus on oxygen. I have 3 times 2, that's 6 and 3. 9 oxygens on this right side and 2 on the left side. So I'll multiply this by 9 by 2. Yes, we can take a fraction. We can take a fraction and this will be 9 by 2, which will give us 9 oxygen atoms. But to make it look more fine, we'll multiply this whole equation by 2. And when we multiply this whole equation by 2, what we will get as a balanced equation is, ultimately, we'll write it like this: 2C3H6 plus 9O2, giving us 6CO2 plus 6H2O plus energy. That's how we write the final answer. The next part is again very simple. They are asking us to find the empirical formula of A. Now this is A here on the top. Its actual formula is C3H6. Now I hope you know this is the molecular formula, not the empirical formula. For finding the molecular formula, we will simplify it. So this is C3H6. It will be written as CH2. This is the answer to this part. Empirical formula is CH2. The next part is asking to name the compound B. Now, compound B is an alkene. It has four carbons, so it's butene. But we will specify the location of the double bond. For that, we will start numbering this. So when we number the carbon atoms, it's carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, and the double bond is coming between carbon 2 and carbon 3. So we'll be naming it like butene. It's very important that we write the location of double bond. So if you will write butene, you will not get a mark. You should write butene, you should represent the location of the double bond. Let's see the next part number F. A structural isomer of B is a member of the same homologous series. Draw the displayed formula of this structural isomer of B. Okay, so the molecule B is actually this. It's CH3CH double bond CH3. So here we have a double bond between carbon number 2 and 3. For drawing its structural isomer, what we can do is we can change the location of double bond. So let's make the double bond between carbon 1 and 2. So it will be CH3, CH2, double bond CH2. So this is the answer. This is an isomer of molecule B. They wanted us to draw the displayed formula of this structural isomer of B. So for drawing the displayed formula, we are supposed to show all the bonds and all the atoms very clearly. So it will be drawn like this: CH3, CH2, CH, double bond CH2. So this is our final answer. This is the displayed formula of isomer of B. In part G, compound B reacts with aqueous bromine. Now this is compound B. It is reacting with aqueous bromine at room temperature to produce C. This is C. State why this is an addition reaction. Now, dear children, I hope you all know that addition reaction is the most common reaction alkenes give. Why are these reactions called addition reactions? Because in this, everything just adds up and you get only one product. So whenever they ask you that why is this an addition reaction, you are supposed to say that because only one product is formed. In addition reactions, always one product is formed. No byproduct is formed. Describe the color change in aqueous bromine during this reaction. Now, dear children, again, you should remember that this specific reaction, which I have written here, is a test for unsaturation. Means test for the presence of more than single bond in molecules. Test for unsaturation. Now, how is this a test for unsaturation? It is a test like bromine water is actually orange in color, and when it reacts with alkenes, it gets another product which is colorless. So when the question asks us that what is the color change that happens in aqueous bromine, we'll say that it goes from orange to colorless. Sometimes we can also call it orange brown or red brown. That also works. So orange or red brown to colorless. Name the product C. Okay, this is interesting. They want us to name this product C. So for that, I would suggest you to just draw its displayed formula. It's like this. Now, when we name it, it is again, we are supposed to number the carbon atoms. So 1, 2, 3, 4, and identify the functional groups. So functional groups are bromine atoms here. So the name is written as 2, 3 dibromo and this is butane. So dibromobutane. So the product is 2, comma 3 dibromobutane. Please note that the numbers are separated by comma and the number and the letter is separated by a dash or hyphen. This is a rule. So we should write it in this way. And no letter should be capital and it should be a continuous name without any space. I hope you understood this. It's very important that we write the position of the functional groups. Like in the above case, we were supposed to write it as butene because at the second position, the double bond was there. That is a functional group. So similarly, here we are supposed to write the location of the bromine atoms. Under certain conditions, 1 mole of B, the molecule B, 1 mole of molecule B reacts with oxygen to form 2 moles of an acid. So, okay, this is B. They're saying this is reacting with oxygen. It's reacting with oxygen, and what it is producing is 2 moles of a carboxylic acid, and they want us to draw the displayed formula of acid. And now, so it means that the bond is breaking from here and we are getting same carboxylic acid twice. So the displayed formula of a carboxylic acid with 2 carbons is, I hope you know that the carboxylic acid with 2 carbons is ethanoic acid and this is its displayed formula. So this is our answer. That okay, this bond is breaking and both of these parts are getting converted to carboxylic acid because they are reacting with, this is reacting with oxygen. So oxygen is getting added to it. So this is how we write the answer for this. Now, when they ask us the name of carboxylic acid, it's very simple. It's ethanoic acid. I hope you know that it's called ethanoic because it has 2 carbons, so eth, and oic acid because it's an acid. In the next part, they are asking us to complete the symbol equation for this reaction. So, okay, this is our compound B. It is reacting with oxygen and it is giving us 2 moles of ethanoic acid. Now, every reaction is supposed to be balanced. So, we have 4 carbons here, we have 4 carbons here because 2 carbons times 2 is 4, and hydrogens are 6 hydrogens on left. And here, how many hydrogens are there on the right side? It's 8 hydrogens on the right side. I think, yeah, here also it's 8 hydrogens. So, we are just supposed to balance oxygen that's left. So it's going to be 2 here because we have 2 times 2, that's 4 oxygen. 4 oxygen on the right. So to make 4 it on the left, we are going to put a 2 here. So that's how we solve this question, which is of 14 marks. And if you will answer it in this way, you will get complete 14 marks. I hope you have understood this. If there is any part that you haven't understood, just put a comment. Thank you so much.